Anybody remember what to do for number 1? What do you think, Andrew? Okay, so we're multiplying. Anybody remember what they're called, the numbers in front? It starts with a C. Coefficients. All right, so you're multiplying the coefficients. I agree. And then you're adding the exponents. Good. So this is called the multiplication property of exponents, when you've got like two things next to each other. All right, so when you multiply exponents, you multiply the coefficients and you add the exponents. Okay, so for this one, just like Andrew said, we're going to do 5 times -2. That's -10. We'll keep the x and x, and then we'll add the x exponents. So 3 plus 0 is going to give me a 3. We'll keep the y the same, and then we'll add the y exponents. 5 plus 6 is 11. So this is the answer to the first one, multiplication property. The second one is division, right? When you have like a fraction. Anybody remember what to do for division? Nate? We're going to subtract the exponent. What are we going to do the coefficient though? We should do different things to them. We're going to divide. So with the coefficients, you're going to do the same operation as presented. So like here, this is a multiplication problem, so we multiply coefficients. This is the division problem, so we divide coefficients. So we're going to divide the coefficients, and we are going to subtract the exponents. And the order that we subtract those exponents is going to matter. So we'll talk about that when we do it. All right, so when I say divide coefficients, 15 divided by 25 is a decimal. You shouldn't write the decimal. Okay, so in your calculator, you have this math frac tool where you can hit like math, enter, enter. So you want to do that. I'm going to pull up my calculator quick. Or you can just simplify this by dividing them each by 5. That's their common factor, but most of you will probably use your calculator. So So 15 divided by 25, you don't want to keep that as 0.6. You want to math, enter, enter that. And we're going to write that as 3/5. So when we divide the coefficients, we'll get 3/5. And then like Nate said, we're going to subtract the exponents. But with exponents, I like to avoid negative numbers. So when I'm subtracting the x's, I want to do 12 minus 9, not 9 minus 12. Okay, if you can avoid a negative, you should, right? So I'm going to have an x to the third. It's just a matter of where that x to the third is going to go. Since 12 is bigger than 9, the x is going to go to the bottom, right? You want to keep the result of that subtraction where the exponent's higher. So for the y's, 5 minus 5 is 0. Does anybody remember what happens if you get a 0? You just don't write it, right? The 5's, they cancel out. I don't need to write that. Y to the 0 means there aren't any y's in your answer. All right, and then I'm going to do 10 minus 3, which is z to the 7th. And since 10 is bigger than 3, I'll put the z to the 7th up top. So this is the answer for the second one. For the third one, this is called the power rule. And just like the previous rules, I am going to do to the coefficients what the rule says. So for the multiplication property, I multiply coefficients. For the division property, I divide coefficients. For the power property, I take the coefficient and I raise it to the power on the outside. So I'm going to do -4 to the power of 2. Does anybody remember from last semester the trick with these? It sure is. So what do we got to do? You could keep it positive or add parentheses, okay? You either know it's positive. Like, understand what -4 squared means. It means -4 times -4. And a negative times a negative has to be a positive, right? If you don't put parentheses in your calculator, though, your calculator is going to tell you it's -16. So just make sure you use parentheses with those negatives. And then, what would we do to the exponents for this one? We've already added, we've already subtracted, so what's left? Yeah, we are multiplying the exponents. Okay, so I'm going to do 3 times 2 and 6 times 2. When you type that in the calculator, you should get a positive as long as you're using your parentheses. The last one is a combination of the blue and the green, okay? So I'm going to do the division first. You don't have to do the division first, but PEMDAS says that you should handle parentheses first, so I'm just going to go in that order, all right? And this is inside the parentheses. So I am dividing coefficients. 2 divided by 3. Math, enter, enter is still just 2 divided by 3. So I'm not going to change that part. Subtract exponents. 9 minus 5 is 4. So I'm going to have an x to the 4th. Would it be on the top or the bottom? Top. All right, so that takes care of the division. And now we've got this power. Coefficients get raised to the power. So 2 to the power of 3, 3 to the power of 3. 2/3 are both coefficients. So both of them are going to get raised to the power, and I'm going to multiply the exponents. So 4 times 3 is 12. And then the only thing I have to do is type 2 to the 3rd and 3 to the 3rd in my calculator. It's not this. It's not 2 times 3, it's 2, and then to the power of is below the clear button. So it looks like this. 2 to the power of 3, 3 to the power of 3. So 8 and 27. The reason that this was your warm-up today is because this unit is heavy on exponents, okay? You're going to see a lot of them. Eventually, we're going to do exponent properties again, but all of your exponents will be fractions. So the property will not change. You will still multiply coefficients and add exponents, but when you do that, it will be fractions. Okay, so it's going to make it a little bit harder, right? Everything we do in this unit that's review, we take it and we add something to it. So we're going to make fractions with those, right? That's not today though, okay? But it will eventually be something that we do. Today we are going to review something that you learned last semester. Nothing that I show you today is going to be brand new. You learned it last semester. How well you learned it last semester is different for all of you though. So I'm going to do a full reteach. Okay, so for some of you it might be a really boring / easy day. For some of you, you might be relearning this as if you never learned it last semester. So we are going to simplify square roots with just numbers and also with variables. The reason that we're doing this is tomorrow we're going to change the square root to a 3rd root, a 4th root, a 5th root, a 6th root, and a 7th root. If you can't do a square root, you certainly can't do a 7th root, right? So I need to make sure you know the basis before we do a little bit of harder stuff, okay? So today we're going to do square roots. We're going to do that in your toolkits and your workbook. So you need both of those copies out. And then you really need this copy throughout the unit. It's on like thicker paper. This is your perfect powers. You can use this on all your quizzes and tests. Okay, so today we're going to focus solely on the x squared column because we're going to be looking at perfect squares. But when we look at 3rd roots, we'll look at the x to the 3rd column. When we do 7th roots, we'll look at the x to the 7th column. So you don't have to memorize your perfect squares. You did have to memorize them last semester, so you probably already know them. But we'll be looking at this x squared column today. So in your toolkit, this section is page 1. We're just going to fill in a few blanks to refresh our memory. If I give you a square root, the first thing I want you to do is check to see if it is a perfect square in the home screen of the calculator. And we do that by hitting second x squared. Those are the buttons that's going to get you the square root. All right, so the first thing we want to do is see if it's a perfect square. How do we do that? We type it into the home screen by hitting second x squared. If when we type that into the calculator we get a whole number, we're done the problem. But if when we type that into the calculator we get a decimal, we've got to move on to step 2, where we are going to type the number divided by x into the y equals screen of the calculator. And at that point, we're going to look through the y1 column of the table, starting with the original number and working our way down. We are looking for the biggest perfect square from your perfect powers toolkit. So again, perfect squares is your x squared column. Take the number from step 3 and the number next to it in the table. And write both under square roots. Type each number from step 4 into the home screen of your calculator like you did in step 1. One will simplify to a whole number and one will not. Keep the one that does not. Is there a blank for yours? Keep the one that does not under, so there's a blank. Keep the one that does not under the root. If you missed any of these notes, they will be on the next screen, okay? All right, so they're up there. First example, square root of 36. Check to see if it's a perfect square in the home screen of the calculator by hitting second x squared. So I'm going to go to the home screen of my calculator, and I'm going to hit second x squared, and I'm going to type 36 in. My notes say that if I get a whole number, I'm done, and if I get a decimal, I've got to keep going. I get a whole number, right? So the answer to this problem is just 6, and I'm done. If I get a whole number, I'm done. All right, I'm going to repeat for the next one. The square root of 54. Okay, so I'm going to type it into my calculator. If I get a whole number, I'm done. If I get a decimal, I've got to go on to step 2. Step 2 says type the number divided by x in the y equals screen. You're not going to do the root 54 divided by x. You're just going to do the number divided by x. Notice the root is not included in this. Okay, so I'm doing the number of the problem divided by x in the y equals screen. And then it says go through the y1 column of the table. This is important, okay? You don't want to go here, because if you go here, you're going to pick the lowest perfect square. You want to look here. This is where the numbers start higher. You want to start your cursor over the number that the problem's presented to you, right? So the number that I want to start with is 54. And what I'm doing is I'm taking this list and I'm looking down the x squared column because we're doing a square root. And I'm asking myself, is 54 in this list? And if it's not, then I need to go down one. And then my next number is 27. Is 27 in this x squared list? No. So then I need to go down one. Is 18 in this x squared list? No. Obviously there aren't any decimals in my list. Is 9 in this x squared list? Yes. So I want to use 9 and the number next to it. So I need to use the 9 and the 6. I like to put the x squared number, the 9, first. It doesn't matter, but just for consistency's sake, you're going to see me put the perfect square first every time. Oftentimes, I find students can get to this step perfectly fine, and it's the next step that they screw up. They simplify the wrong one. So I recommend taking this and typing them both in the home screen, right? Just to double check. So I'm going to do a 9 and a 6. The one that becomes a whole number is the one that goes away. The one that's the decimal is the one that stays. So you can see the square root of 9 becomes a 3. So I'm going to change the square root of 9 to a 3. The square root of 6 is a decimal, so I'm going to leave the square root of 6 the same. So this is 3 square root 6. You can always check your answer like this. Root 54 is this weird decimal. 3 square root of 6 is this weird decimal. This is a really good strategy for multiple choice tests. You don't have to do any work, right? Type the question in the calculator and each answer. Only one of those decimals is going to match, and you don't even have to do the work, okay? So 3 root 6 would be correct because I can see those decimals match. All right, letter C. And again, I feel like I'm moving a little fast. It's just because you've learned this before. All right, so letter C. In my home screen, I'm typing the square root of 500. I get a decimal. If I get a decimal, I'll go to the y equals screen. And I'll do the number, which in this case is 500, divided by x. You want to start your cursor on 500. And I see on my list that it doesn't even, my x squared list doesn't even make it to 500, so my chances are that it's not a perfect square. So I'm going to go down, 250. My list makes it down to 256, but I don't see a 250 on the x squared list, so I'm going to go down again. There's no decimals on this list. 125, I see a 121 on my x squared list, but not a 125. 100, I see that. Okay, so I'm going to use the 100. And I'm going to use the number next to it as well, which is a 5. I'm going to start with the 100 because that's the number on the x squared list. That's my perfect square. So I've got my two numbers, and then I just want to check each of them. So I'm going to check the square root of 100, and that's going to change to 10. And the square root of 5 is a decimal, which means it's not going to change. I'm going to keep it as the square root of 5. So 10 square root 5. And one more final check would be the square root of 500, comparing that to 10 square root 5. If I'm right, the decimals will match perfectly. If I'm wrong, they won't. So you can check your answer for all of these. All right, you guys take a moment and try letter D if you haven't done so already. .343, not a perfect square. Did anybody find a perfect square that was divisible by 343? What'd you get, Andrew? 49. All right, so 49, and then what was next to the 49?
7.
A 7, okay. And then if you check each of those individually, you should get 7 root 7. The square root of 49 is 7. The square root of 7 is a decimal, so I leave it that way. Anybody have questions? You learned it last semester, so I did go through it a little quicker, but I do think a refresh was probably important. All right, so you're going to take a quick moment to do some practice with a partner or a group of people or on your own. It doesn't matter. I don't think 10 minutes is necessary, though. I'm going to go more like 7. 7 minutes, okay? So I'm going to post answers in 7 minutes. You're working on this with a partner, with a group of people. It doesn't really matter, but we'll go at 8:10. We'll go over the answer. This is page 4 in your workbook.
let's see if you get the right one. First column, almost at the bottom. It's the point of the first line. And the second line is. Second line. Second line.
All right, what's the square root of 100? 10. What about 169? What about 144? What about 256? All right, those were all whole numbers. You didn't have to do any work. All right. What perfect square went into 24? 4. Good. So 24 is going to be split up into 4 and 6. 4 being your perfect square. I'm just showing the table and like what I was looking at there. What perfect square did you get that divided into 27? 9. Right? So this one's 9 and 3. What perfect square went into 128? 64. And then next to 64 would be a 2. Just be careful. I'm showing you in the table. You could have picked 16 and 8 too, and you would have been partially correct. Okay, but not fully correct. So I have it in red. You want to pick the highest perfect square, and sometimes there's more than one perfect square. You got to make sure you're picking the highest one. So really start your cursor at that 128 and go down one by one, and each number check with that list. You have a list now physically in front of you with an x squared column. So look at that list as you go down. And then 700 was 107. Hopefully you guys feel okay with that. All right, the second half of class here, I want to review with you how to simplify variables, okay? I think variables are actually easier than regular numbers because with variables, all you have to be able to do is divide. Specifically, divide by 2, which is a pretty easy thing to do. So if the number is an even number, divide by 2 and drop the root. You are done. But if the exponent is an odd number, then you need to split it into the highest even number less than, I'm just doing a symbol for space, the exponent, squeezing that in there, and the exponent of 1. The second exponent will always be 1. Hopefully that, once you see an example, it will refresh your memory. It might not mean much in words here. Divide the even number from step 2 by 2 and drop the root. Keep the exponent of 1 under the root. This idea is going to stay the same tomorrow, except when it's a third root, everywhere you see a number 2, we're going to change to a 3. If it's a fourth root, everywhere you see the number 2, it'll change to a 4. So with exponents, you're still just dividing, but now you'll be dividing by different numbers tomorrow. Today is a square root. Everything is a square root, and when you square something, you take it to the second power. That's why we're dividing by 2, okay? That's the significance of the number 2. A square root is 2, all right? So looking at our examples here, the first example, A, is root 24x to the 10th. It's important for you to remember that what you do to a coefficient, you never do the same thing to an exponent. Just like in our warm-up. Every time we did something to a coefficient, we did something completely different to the exponent. So this coefficient of 24 gets treated differently than this x to the 10th. I like to write them separately to separate that idea. You just did the square root of 24 when you worked with a partner, okay? We talked about how 24 divides into 4 and that the number next to it was 6. And we ended up with 2 root 6, all right? You just did that one. Now, if you're working with a variable, the first thing you're going to do is see if the exponent is even. If it's even, you're going to divide by 2 and drop the root. So I'm going to divide this by 2, x to the 5th, because 10 divided by 2 is 5, and I'm going to get rid of the root completely. So the square root of x to the 10th is x to the 5th. You are done. Okay? When it's even, you don't have to do a lot of work. Now, what you're going to see me do at the end here is reorder my answer. This 2, I'll say, doesn't have a roof over it. There's no roof, right? It's not in a house. And this x to the 5th doesn't have a root over it. It's not in the house. That makes them like terms. So what I'm going to do is I'm going to write those two things next to each other. And yes, you have to do that. You have to combine your like terms by writing them together. And then this root 6 is on its own, so it just tags along at the end. Everybody okay with that one? All right, test taking strategy. Because it has a variable in it, I can't check my answer in the home screen like I showed you before. Like when I wanted to check the square root of 500, I could do 10 root 5 and check it. You can't do that with this one. You have to check it in the y equals screen, okay? So in the y equals screen, in y1, you can put the original problem. And in y2, you can put what you think the simplified form is. Nope, it was 2, right? If you're right, the tables will match. Okay, so if there's a variable in it, you still can check your answer. You just can't check your answer in the home screen. Questions on that one? Okay, let's go back there. All right, so for the next one here, again, it's important for you to recognize that you have to separate these. So I'm going to do the coefficient as one root and the x to the 81 as a separate root, just to separate those ideas. What do you know about the square root of 49? 7, if you type it. Remember step 1. Type it into the home screen of your calculator. If you get a whole number, you're done. This is just 7. Now, a lot of times kids want to tell me that the square root of 81, x to the 81, is x to the 9. But it's not. Because with exponents, if the exponent is even, we can divide by 2 and drop the root. But 81 is not even. If it's odd, you need to split it up. You need to split it up into the highest even number under the exponent, which is usually just 1 under it, right? The highest even number below 81 is 80. The second exponent will always be a 1. Together, that's 81. Okay, so I'm not changing the value of the problem. What I'm doing is making an even number so that I can divide by 2, right? So highest even number under the exponent and an exponent of 1. Divide the even number by 2 and drop the root. Keep the exponent of 1 under the root. And then this 7 is just coming down. Now you can leave your answer like that, but you don't have to write the 1. The 1 is just a placeholder number. And so that would be my final answer here. 7x to the 40th root x. Again, because it has a variable in it, I can't check it in the home screen, but I can check it here. So the square root of 49x to the 81, that's the original question. 7x to the 40th square root of x is what I think the answer is. And you can see everything matches, right? If I do something wrong, those aren't going to match for every single value. All right, for the next one, I'm going to look at simplifying the square root of 128, which I believe you guys just did on page 4. Can you peek back to page 4 for me?
Yeah.
What perfect square did we pick for 128 on page 4? 64 and 2? So you just practiced this one. So I'm going to just kind of go through that quick. 8 root 2, okay? So now we're going to do x to the 15 and y. Now that y right there doesn't have an exponent on it. So what could I give it? What's my placeholder exponent? 1. You don't want to do a placeholder exponent of 0 because that means there aren't any y's. And there is a y. Okay, so I'm going to put a 1. If the exponent is even, divide by 2 and drop the root. You're done. Neither of these are even. So I got to go to step 2. If the exponent is odd, then split it into the highest even number under the exponent. What's the highest even number below 15? 14 and 1. What's the highest even number below 1? Nothing. I can't do anything here. Because splitting this into 0 and 1 is going to get me right back to where I started. Look. Well, y to the 0 literally just means this isn't here. There's nothing you can do with y to the 1. You're just going to have to leave it under the root. It's not going to simplify. All right? So for the even numbers, divide by 2 and drop the root. So that's just x to the 7th. Keep the exponent of 1 under the root. Keep the exponent of 1 under the root. All right, so here's where we're at. Now I'm going to reorder this. I'm going to take this that has no roof over it and this that has no roof over it, and I'm going to write them together as 8x to the 7th. All right, I'm going to take this that has a roof over it and a roof and a roof. And instead of writing them under different houses, I'm going to put them all together under the same roof. So it'll be 2x, y. Now, unfortunately, because this one has 2 variables in it, you can't type it in the y equals screen. Because the y equals screen already uses the y term. So you cannot check this one in the calculator. The only way you could check this in the calculator is if you ignored the y part of the problem and just checked the 128x to the 15th. You could check that. You just would not include y in your answer. Make sense? All right, so you guys try D. You're looking at 80, and you're doing that the way we did the first half of class. Go to your y equals screen, 80 divided by x. And then the variables you're doing differently. find a perfect square for 80? Perfect square. What is it? 4? I think there's a higher one. 16. What was next to 16? 5. All right. So if you're typing 80 divided by x and you're starting at 80, and then the next number's 40, you're just going down and you're working your way through that list. Eventually you'll hit a 16, okay? And that becomes a 4 root 5. X to the 16th is an even number. The square root of x to the 16th is not x to the 4th. What is it? X to the 8th. Divide by 2, drop the root. It's just x to the 8th. I'm going to split 23 up into 22 and 1. So divide the even one by 2, drop the root. That's y to the 11th. Keep the y1 under the root. And then you're going to reorder. So the house numbers go together. So I'll have a 5y under the root and a 4x to the 8th y to the 11th in the front. So 4x to the 8th y to the 11th root 5y is the final answer for this one. You cannot check that in your calculator. Multiple variables you can't check in your calculator. We are going to end class today with practice the same way we did in the beginning. You can find a partner. Now before you get up, I just need you to remember that. If this is hard for you, tomorrow's going to be a real struggle. So if you're struggling, find a friend that can help you or come work with me, all right? I want to make sure you're okay with this before tomorrow. Tomorrow we're going to do it a little bit harder, so I want to make sure you're good with today. So this is page 4, numbers 9 through 16. I'm going to go over answers at like, I'd say 35-ish, so I can make sure I have enough time to post them, all right? So a little bit under 10 minutes. Feel free to work with people as needed. So 6 divided by 2 is 3. Drop the root. X to the 3rd. For the second one, I had to split this up because it wasn't even. So I split it up into 12 and 1. I can divide 12 by 2 and drop the root, but I can't divide 1 by 2 and drop the root because I'm looking at a decimal, so I left the 1. In my answer, I'm just showing me crossing off the 1 because you don't need to write that. On a test, I wouldn't care if you wrote the 1. But on a computer assignment, they do care, okay? So technically, x to the 1 isn't fully simplified. You don't need to have the 1, all right? For the next one, I split this up into the x into 10 and 1. For the y to the 20th, I didn't have to split that up because it was already even. And then you'll see in my final answer, I just rearranged the order. And then I did this one up top here, okay? So 30 and 1, 8 and 1, and then reordered the answer. For 13, I had to do the 147 differently than I did the 8. So I had to do 147 divided by x and look for my perfect squares. And for the 8, I just had to divide by 2 and drop the root. And then I reordered my final answer. 36 is a perfect square. It's just 6. But 7 is an odd number, so I wrote it as 6 and 1. You'll see I don't have the 1 in the final answer. I just wrote x. 175 splits up into 25 and 7. 23 splits up into 22 and 1. The square root of 25 is 5. The square root of x to the 22nd is x to the 11th. I can't do anything to the 7 and 1. 243 breaks up into 81 and 3. Oh, x to the 11th breaks up to x to the 10th and x to the 1st. All right? So simplifying square roots. Does anybody have any questions on any of those? Disagree with any answers? anytime I type something on math type, I am likely to make a mistake. So if you see anything, let me know. What's that?
Can I use the calculator charger?
Yep. Guys, we don't have any homework tonight. I will eventually get your midterms back to you, but there are a few people in this class that didn't take it yet. So I'm trying to wait until that's done, and then I will get it back to you this week. But your scores are in Canvas. Sorry, Power School.